Great. All right, so my talk is about the neurobiology history, the inspiration from neuroscience research that is behind the deep learning that has taken over the world today. So the illustrations that you see in this deck, they're by Agley Bassins, who is the illustrator of Deep Learning Illustrated. And yes, here we are at the holiday book party. So this is a guy named Frank Rosenblatt. Frank Rosenblatt was a computer scientist in the 1950s, and he was inspired by the way that biological brain cells work. So biological brain cells, they have many inputs that we call dendrites, and each of those inputs carries an electrical signal from other brain cells in your brain that aggregate in the cell body. And then based on the aggregated information from all of these inputs, an individual brain cell decides to either fire its own electrical signal or not to. And so your biological brain cells that you have in your brain have many inputs and only one output, and that output is binary. It either fires or doesn't fire. So this, our early understanding in the 1950s of how biological brain cells work, inspired Frank Rosenblatt to create an artificial neuron that followed the same kinds of ideas, roughly speaking. So an artificial neuron is a simple algorithm that takes in many inputs. It does a weighted averaging of the inputs, and then based on that weighted average, it decides to either output or not output some value. So typically in his original way that he created them, they outputted a 1 or a 0, depending on the weighted sum of inputs that were fed into it. And so these artificial neurons can be arranged together into a network so that you could have many layers of them, just like your biological brain has many layers. So this idea of artificial neurons that came up in the 1950s, it is the same technology, the same concept, all of these decades later, 70 years later, 7 decades later, that is behind the machine vision algorithms everywhere, for example, that can recognize your face and unlock your phone, the natural language processing algorithms that can recognize your voice and activate your home device, deep learning with these same kind of artificial neural networks is behind technology called generative adversarial networks that allow us to create really compelling fakes. So these are two fake people, images that were made up by training a deep learning network on high resolution celebrity photos. And deep learning is even behind the kinds of AI systems we have today that do complex sequential decision making, like self-driving cars, for example. So I mentioned to you that we have these artificial neurons. We already kind of looked at how they work. They have many inputs and one output, and they can be somewhat powerful on their own. But the real power of these artificial neurons is when we layer them together. And this, again, this idea of layering these artificial neurons comes from the way that your biological brain works. So when you look at something, say you're looking at a mouse, a huge amount of information is taken from your eyes to the back of your skull to an area called the primary visual cortex. And so there's just tons and tons and tons and tons of information coming from this raw photons pounding your eyes. And so in order to take all of that visual information that's pounding your eyes and convert it into something that's useful to you so that you can pick out a mouse from all of the other visual stimulation around you, you have these layers of brain cells that do increasingly complex computation. So the very first brain cells in your primary visual cortex that receive the photons of light, the information about the photons of light from your eyes, those are called simple cells, and they can detect straight lines only. And then they pass information to a second layer of cells, which we can call complex cells. And these complex cells can recombine information from the first layer, so straight lines, into corners and curves and other kinds of simple shapes that are created from just some straight lines. And then as we go to a third layer, that third layer can recombine the curves and corners into increasingly complex, increasingly abstract shapes. And then through several subsequent layers of processing, indicated by these hatched lines here, you can start to have a visual representation of a very complex visual object, like a mouse, a cat, a bird, a dog, or anything, really, anything you can see with your eyes. So this is how your biological brain works. So we have, in total, with my, with the hatched lines here, you have many, many billions of biological brain cells in your visual cortex that allows you to see. And so we know, for example, that primary visual area that I was talking about right here at the back of your brain is dealing just with straight lines. And as you go further and further away from that center there, from that V1 area, the brain is doing more and more complex processing, such that in the human brain, for example, there's this area over here, right at the edge of your visual cortex, which is back here. The fusiform face area, right at the edge of it, is specialized to detect faces only. So if you happen to have brain damage just to that area, you'll lose the ability to recognize human faces, but will otherwise have no cognitive deficits. So this is the second way, the second major way that neurobiology has inspired deep learning. So earlier we talked about the artificial neurons, the individual components of a deep learning system, and now you can see the inspiration for how we layer those artificial neurons in order to do really sophisticated processing, such as in a machine vision system. So here we have a machine vision system called Alexnet, which was the absolute state of the art in machine vision in 2012. And you can, and kind of broken down here, it's just layers of artificial neurons. So it's the same algorithm as we had from the 1950s, but we just layer lots of them. So you have 1, 2, 3, 4, 5, 6, 7, 8 layers of artificial neurons here. On the far left, we have some input image. So we have a 224 by 224 pixel image that is fed into the network. And then the network learns by being provided millions of training images, as well as labels as to what those images are. So in this case, we have 1,000 different categories of images. So some of them are ships, roosters, dining tables, grocery stores, dogs, wheels, all kinds of things. And based on that training data set of images and labels, the intervening layers of the deep neural network, the deep learning system, they automatically figure out what the most important things they should be recognizing are. So in the first layer here, just like in the first layer of your brain, the artificial neurons in this layer can recognize straight lines and straight lines only. So they recognize straight lines at different orientations. So in this particular deep learning architecture, there are 96 artificial neurons, and you can see what each one of those 96 is specialized to detect here in this matrix. And then as we go deeper into the network, by this third layer, we've recombined straight lines into curves and corners, and by this third layer into textures. And you can see 9 examples of what the artificial neurons in that layer are specialized to detect. And then just like in your biological system, as we go further to the right, as we go deeper into the network, we can have more and more complex, more and more abstract visual imagery handled by the system. So by this layer here, we have artificial neurons that specialize in detecting dog faces or clock faces or wheels. And then through a few more layers of processing, we can then output a probability that any given input image is one of these 1,000 possible classes. So it's a ship or a grocery store or a dining room table. So that, in a few minutes, is how deep learning works. And that is the basis of my book, Deep Learning Illustrated. So the opening pages go over in more detail the story that I just told you. And so Agley Vassins, the illustrator, this is an illustration of herself, a self-illustration shown on my slides now. Grant Bailevelt was my co-author. And yeah, there's the book. If you want to get 35% off, there is a code there if you're not one of the lucky winners for the giveaway that we're giving in a second. You can also get it on Amazon and that kind of thing. And so please do stay in touch. I would love to be in touch with you. Feel free to connect with me on LinkedIn and just mention that you were at the holiday book party, and I will definitely accept your connection request. I have a YouTube channel with lots of free videos on machine learning and deep learning, particularly the mathematical foundations of machine learning is something I've been releasing a lot of videos on. So new video every single Wednesday. I do tweet if you prefer that over LinkedIn. And I'm host of the Super Data Science podcast. We have new episodes every Tuesday and Friday. Kate Strachnyi was herself a guest on the show at the beginning of the year. She was one of my first guests ever on the program, and it's such a fun episode. You can check that one out. And yeah, if you want to be sure to not miss any of my content when it comes out, almost everything that I release is free. So if you sign up for my email newsletter on jonkrohn.com, you'll get a notification about once a month of all the new content that I've created since the last newsletter.
Awesome.
And we all love your content, Jon.
Yes, thank you so much, Jon. I always feel like I get just a little bit smarter when I listen to you speak. So this is great. Thank you so much for the presentation. I know we have some giveaways and we do have some questions. We didn't talk about lifting weights yet, but
Yeah.
we'll take a question here from Mike. And he says, great presentation. What are your thoughts on the new Google Pathways ANNs?
I'm afraid I've never heard of it. So they must be pretty new, or I'm just out to date here. So I don't know.
I was going to ask you to define an ANN, so I guess we're
So
not.
that I can do. So an ANN is just an artificial neural network.
Okay.
And so everything that I showed you in my slides, so we started off with a single artificial neuron.
Yep.
And then I showed you how we can layer them together into an artificial neural network. So it's just this idea of a bunch of artificial neurons connected together. And if you layer more than 4 layers of artificial neurons together, we can call that a deep artificial neural network or a deep learning architecture.
Mm-hmm. Okay, interesting. Yeah, we have some comments come in. Christine says the performance of neural networks is fascinating, and she loves that the book is illustrated. And I agree, the illustrations are really, really pretty. And I know you showed the self-illustration for your illustrator as well as your co-author. I didn't see one for you, so I'm assuming it's there somewhere. Did she illustrate you too? Or?
There is one, yeah. I guess I felt like maybe because I had the Super Data Science thumbnail there that I didn't want to have too many illustrations of myself.
Okay, all right. Well, that's fair. And we see you here live, so that
works. Me. You don't need an illustration of me. I look almost exactly like this in real life.
Okay, perfect.